Right, so another type of equations today. So previously we saw to solve equations with one variable, only x. So we solve the equations with one variable, x only, or n, or some other letter. Today we're going to see how to solve equations, linear equations, but with two variables, not just one. So we call them linear equalities, linear equations. So basically linear equations we say into or with two variables. In two variables. Not just one, but two variables. Okay, so it will be something like this: x plus y equals, for example, 4. So that's an equation in two variables, not just one. For example, what would be a pair? What would be a pair of x and y that would make this a solution to the equation?
2 and 2.
2 and 2. That's a possible solution. That's right. 2 and 2. Or what other?
1 and 3.
1 and 3. 3 and 1. Of course, you can throw in a negative on the positive, for example, -1 and 5. So this could have many solutions in forms of pairs. We have literally infinitely many solutions for this pair. Because it's an equation with two variables, it's also linear. So basically, the solution of this equation is many points. Each one of these is a pair. Basically, is a point on a graph. So the solution to this equation is a straight line with many points. Each point, again, is a pair of x and y. X and y. We're going to see later how to solve equations. These equations, we usually solve them by graphing. So we need to put them on a graph, put a line like this, and the line would be the solution to the equation. We'll see that later in detail. Okay, so I'm just giving you a little heads up here. So that's basically what we do when we have the equation with two variables, x and y. We has many solutions. Unlike the equations we saw before, x, for example, is 2, and that's it, or x is -5. There's one solution only, but with these we have a pair of solutions. Many pairs, actually, many pairs of solutions. So we call this an equation in two variables. The standard form, they all look like this. So there's always x and y in the equation and some number on the other side, some c, for example, 4. And they could be numbers or coefficients next to the x, for example. There could be a here, there could be b. So there's some coefficients. For example, here the coefficients are invisible, they're 1 and 1. But it could be 2, 3, -5, 7/2, could be any sorts of real numbers. So that's basically how second degree equations, not second degree, first degree equations with two variables actually look like. So all will have this form. And the way we solve these, again, because we have too many solutions, it's not like the regular equations when we solve and find one solution, or sometimes there is no solution. So we have many solutions. Again, the solution has to be a graph, has to be a straight line, which basically contains all the points, all the pairs that make the equation true. Now let's check, for example, we said that the pair 2 and 2 is a solution. We can check it, we can plug this into the equation, 2 and 2 into the equation. So the pair is always made of two numbers, x and y. So if you plug 2 here, plus 2, we say, is it equal to 4? Yes, if we check, 4 equals 4. What about, for example, 3 and 5? Would 3 and 5 be a solution to this equation?
No.
Would not be a solution, that's right. Because if you plug x and y in the equation, it would be 3. So y is 3, I mean x is 3, y is 5. we say is it equal to 4? Apparently not. This is 8. It's not equal to 4. So this is not a solution. The pair is not a solution. But this one is a solution. So the pair is a solution. That's basically, at least we can check the solutions. May give you an equation, we give you a couple of pairs and ask you to check whether a pair is a solution to an equation. So that's an example here. We give you another equation. For example, 2x minus 3y equals, I don't know, maybe 7. So that's an equation. Again, the numbers here change. As you can see, we have 2 and negative 3. So we're going to check a couple of pairs. We check 2 and negative 1, or actually 3 and 1, then check 2 and negative 1. So the solution, because the equation has 2 variables, the solution is a pair. It's a pair of x and y values. It has to be a pair. If there's a solution, it has to be a pair. And later we're going to see how to graph the pairs. So let's check again the first one. 3 and 1. So the first one is always x, second one is always y. So we're going to plug them here. Plug same way we did with the evaluating of expressions. We're going to plug these here and see what we get. So if we plug this into the equation, what do we get?
2 times 3.
That's right, 2 times, just like we did the evaluation, 2 times x is 3.
Minus 3 times 1.
That's right, 3 times y, the y is 1, or, yeah, that's 1. So in this case, 1. And we're going to say, is it equal to 7? So just like we evaluate in the expressions, we plug and simplify. Then we use all of operations to simplify. Of course, the multiplication first, that's 6 minus 3. We say, is it equal to 7? 6 minus 3 is 3. 7. 3 is not equal to 7. So what do we say about this pair, since it didn't work out?
It's not a solution.
It's not a solution.
Exactly. So this pair is not a solution to the equation. And that's it. We move on, check something else. Now let's check the other one. 2, negative 1. Same way again. It's always x and y. So we're going to plug both of these into the equation. So 2 times x, whatever the x is, minus 3 times 7 equals 7. What goes here inside these numbers, these parentheses?
2 and negative 1.
That's right. So x goes here, 2 times x is 2. Multiply y, which is negative 1. We're going to see whether that's equal to 7 or not. So again, we're going to use the order of operations to simplify. So that's 4.
And then positive 3.
Positive 3. That's right. We say, is it equal?
And it's 7.
Of course, 3 plus 4 is 7, equals to 7. So that's good. So this pair is, this pair here to the equation is a
solution.
A solution.
Exactly. It is a solution. So that's how we at least check. So solving this is better done with a graph because we have many points. You can just look at them. You can make up points. It's better to represent the solution set with a straight line, a line made of all the solutions, basically, all the solutions of the equation. And so let's see how to, for example, this one here. These are a couple of pairs we tried. This is not a solution. This one is a solution. But let's see how to graph the line. Let's see how to graph a line that represents all the pairs. See how to graph it. So call that graphing. Linear equations. And again, these have two variables, x and y. So because they have two variables, x and y, so the graph will have two axes. We're going to have the x-axis and the y-axis in order to graph an equation with x and y. Let's take the same one, simple example here, x plus y. So again, 2 and 2 is a solution, 3, 1, 1, 3, and so on. All those pairs are part of a line. Each one is belongs to a line. And to find that line or to graph the line, so here's what you do. First, we need to find some points. We need to find some pairs. You can choose some values here and find the other value. You can either choose x and find y or the other one. So I'm going to make a table basically with a few x and y values. For example, we're going to suppose x is 2. Then we're going to find what the y is. Or we may have the y. We're going to try to find the x or the other way around. For example, maybe 1 here and find the other one. So this table basically, just going to write a few pairs that make the equation true. For example, just by looking at the equation, if x is 2, y must be what? Or this to be 4, it has to be. If x is 2, what should the y be?
Serious?
To get 4?
2.
Should be 2. That's right.
Oh, sorry.
What if the y now, the y is 1, what should the x be? Or this to be 3?
3, yeah.
Should be 3. That's right. Because if you add them, x plus y is 4, x plus y is 4. The last one here, if x is 1, what should the y be? For this to be 3?
3.
To be 4? 3.
3.
All of these are solutions, and you can keep going. You can choose any number you want from here, and you can find the y, or you can choose any y number, and you can find the x. That way, when you combine the two, you get 4. So basically, we just completed this table or this pair, these pairs. So we have a pair here, we have 3 of them. If you have one, we can find the other. Let's see how to actually do it. It's not always this easy because this is very convenient. Let's actually see how to do this, regardless of how complex the equation is. So completing the pairs, or we call them ordered pairs. Why we call them ordered pairs? Because they're not random. They have to be certain, has to be a specific pair to be a solution, because this is not a solution. This is not an ordered pair or a solution, but this one is. So these numbers are not random, they're ordered. So together they make a solution to a certain equation. So here's how you actually solve or find the missing value. So for the first one, basically, for this one, x is 2, but the y was missing. The y we didn't know. So we had to find the y. So this is how you find the y with the equations. If not, it's not this easy. Basically, you plug what you have, you put it into the equation and solve for the other one. So we're going to plug the x into this, then find the y. Again, the y was initially unknown. We just found it. We did the math to find it, but this is the actual equation that you do to solve it. So plug x in the equation and solve for y. Or if you have y, you would plug the y and solve for the x. So the equation will become, so x, again, x is 2. I'm going to plug 2 here, plus y, which we don't know yet. And we solve this very simple equation. We solve it for y. to find y. Again, initially we don't know the y, so it's not there yet. So if x is 2, what is y? We know it's going to be 2, but let's solve it. Let's found it through solving equations. So what do we do here to solve this equation for y? One step.
Oh, move the 2 to the next to the 4 with the
Okay. Or we can
another
cancel it,
sign, like minus
can-
2. Oh, yeah.
Subtract it on both sides.
or we can subtract it from both sides. So if you cancel it from both sides, would be same thing. So 4 take away
That will
2 is 2.
Y will be
That's
2.
why we said y is 2. So basically we solve the equation. And pretty much do the same thing for the other one. So now if 1 is 2, if one is y is 1. So we complete this pair. So if y is 1, x we don't know. X here we don't know yet. So we need to find it. So again, we can take what we have. We have the y. So we're gonna this time plug the y and solve for x. So it's gonna be x plus the y, which is 1. That's equal to 4. Then solve this for x. Easily again, one step. What do we do here to find the value?
-1.
Find x. Minus 1 on both sides. That's it. X is 3. So the other pair is complete. And of course, we set for the other one. If x is 1, this would be 3. Or you could do it the same way. So it's not always this easy. It's not always easy to just complete by looking at the numbers. For example, here, for this equation, it won't be easy to face set, for example, x is 5. It's not going to be easy to find y just by looking at it. You will have to plug the x and solve for the y. And you can put in any numbers. You may have a number, you may have a table to complete, or pairs. It could be like this, 2, and the y is missing, or it could be like this. The x is missing on the y. So it'll be given to you as a table or as pairs, as incomplete pairs. So you complete each one by plugging in what you have. So that's the first thing. So you complete the pairs or the table you have, or you can make up your own table. If you don't have a table, feel free to choose a couple of values, either the x or the y, whatever you want to do, and find the missing ones. Now, this will turn into a graph, turn into a line, either this way, that way, this way. It will depend on these points. So let's see how to exactly draw the line. So the solution is a straight line. Not only these numbers, these are just a few of them. We have many, or literally we have infinitely many pairs. So the graph always looks like this. We have a horizontal line, that's for the x. The vertical line, axis, we call this the x-axis. This is the y-axis. And this is basically the number line we talked about before. This is another number line, it just goes vertical. So we have 1 here, 2, 3, and so on. The other side, what kind of numbers do we have on the other side?
Negatives.
Negative. So -1, -2, -3, -4, and so on. And for the vertical number line, so it starts from 0. So everything is 0 here. Both x and y are 0. So up here, the numbers are positive. And down here,
Negative.
below 0, the numbers are
Negative.
negative. So we have -1, -2, -3. That's how you make a graph yourself. It's not easy, it's not hard to make. Or you can use graphing paper. After this, I'm just going to use a copy and paste a picture of a graph that looks like this, an empty graph, and we're going to put numbers on it. But it is easy to make your own. If you don't have graphing paper or something, you can make it quickly. It's not that bad. Okay, so we have the equation. We completed the pairs. No, we're going to turn these two pairs of 3 into dots. And then we join those dots with a line. The line would be the solution. So we're going to plot. We're going to plot, we say, plot these into this. So all these pairs, we have 2, 1, 3, 1, 1, 3. So this is how you graph them, or how you locate each pair, each point. For example, we're going to call this A, B, and C. Let's find this point, this pair, 2, 2. So you start from the X. You're going to start from this. First value is the X, which we find on the X-axis. In this case, it's 2, so it's right here. Then from this one, we go to the Y. We go vertical. We either go up or go down, depending on the sign of this. If this number is positive, we go up. As you can see here, the numbers are positive. Or if the Y is negative, we go down. Or if the Y is 0, what do you do if the Y is 0? If you start from 2 and the Y is 0, what do you do?
Plot it on the line.
That's right, we stay on this line, because if it's a 0, we don't go up, we don't go down. We're gonna have to stay on the line. So in this case, start from here and go up 2. Start from the X, go up vertically, 2 units vertically. 1 and go up 1, 2. That's the first point. This is the first point, A. So if you drop it over here, the X is 2. If you drop it over the Y is 2. Let's do the other two the same way, 3 and 1. So to plot this point, 3 and 1, or the point B, what exactly do you do on the graph? Where do you start and where do you go?
You start at 3 and go up 1.
That's right. And
The
start-
3 that is in a X line.
That's right. 3 on the X line. And then from here,
Mhm.
positive 1, we go exactly once. It has to be vertical, up or down, not right or left. Vertical. And if it's 0, we stay here. But in this case, it's 1, so we're going to go up once. This is the point B. Finally, 1, 3. This time, we're starting from X1, which is here. Where do you go from there?
Up 3.
You go up 3. That's right. So X is 1, the Y is 3. This is the C, the point C. And once you plot your points, all of them, let me just rewrite these. So we have point A, point B, and point C. This is again the Y-axis. This is the X-axis. Stand it a little bit. When, what do you notice about these points? What shape or what graph, kind of graph are they making together, these points?
A line.
That's right, they make a line, and they have to. So if there are solutions to the same equations, they must all belong to the same line, as you mentioned earlier. So now, these belong to the line or the solution set of this equation. It has many, many, many pairs. This is just 3 of them, but we have literally infinitely many, as I mentioned, of solutions or pairs. The next thing to do now is just to draw the line here. This is when you grab a ruler. When you're doing it with paper, you grab a ruler, make sure your line is straight, and it goes through all these points. So the solution or the graph of this equation is this one. So all these points. So a line, the definition of a line is basically an infinite number of points. We have too many points here. Each one has X and Y. Each point has X and Y. And each one of them is a solution. So if you take any other point from this line, for example, this point, what are the coordinates of this point, by the way? What's the X and Y of this point, approximately? What is the X and what's the Y of this point?
think the x is gonna be positive 4.
Now the 4 is here, so we have 3 or 4. This is about 5. Okay. What about the
So
y?
5,
The
negative
same point.
1.
And the y would be negative 1. So this point, if you plug x 5 and y negative 1, what is that equal to? It will be 4. Okay, because it belongs on the line. Same thing, this point here. What are the coordinates of this point, by the way? What is the x and y? Start with the x. If you drop this over
Okay,
the
so
x.
it's gonna be 4.
Minus 4 and 4.
No, drop this over the x first. Drop it vertically. What is the x?
Negative 2 and 4.
Now this point, just drop it over the x-axis. What would the x be if you drop this vertically? What is the x here?
Oh, 0.
The x, that's right, is 0. And the y, of course, we are on the y. What is the y?
So it's gonna be 4. Positive
The y
4.
here is 4. So that point also, if you put this point here, you'll see it will also be 4. The point here is 0 and 4. So you put 0 plus 4, it will also be 4. That means it's a solution. All the points belonging to this line, you can get the x and y easily. And if you plug that into the equation, it should work. So that's why the line is a solution. So solution set is a line. This line here. And that's pretty much the same process every time you graph or you want to solve a linear equation, you want to graph it. You complete some point, you need at least 2 points. To graph a line, you need at least 2 points to be able to draw a line through it, at least 2. And however many points you choose to complete, they should all belong to the same line. So, and again, you can take any point from here, you plug it, it will work. But if you take some other point, not belonging to the line, for example, this point here, what are the coordinates of this point? What are the x and y here?
It's going to be your positive 1
X
and 3.
positive 1, x
So-
positive 1, and the y is?
Positive 1. Wait, you said x is positive 1?
No, this point, the x and y, the
Oh,
coordinates.
yeah. Right, and
It's
so
one-
it will be
one.
1.
And 1. And because this point does not belong on the line, it's not going to be a solution. If you put
And
it here,
x
it would
is
be 1
always
plus
first,
1.
right?
So if you plug this point here, 1 and 1, in the equation, it's not going to work because it's not on the line. But only the numbers that are on the line, the points, when you put them in the equation, they work. So that's how it works when it comes to solving linear equations with 2 variables or graphing them. That's what we do to graph them. We're going to do another one, but before that, any questions, everybody, about any of these steps here? Everyone, please let me know. Okay,
No,
please let me know if you have any questions here. I'm going to do this a few times. Let me give you another one. Let's take another equation. Maybe not as simple as this one. Let's say 3x, maybe minus 6y, and maybe 12. Same idea. So this equation is a linear equation. It has many pairs. Maybe not as easy as this one to figure out the pairs. Okay, this one was easy. 2 numbers that add up to 4, could be any of these or something else. But when it's a little different, it's a little difficult. So we know what to do. We're just going to do the same thing. So we know that the solution is going to be a straight line. So we need to find some points to know exactly how to draw the line. A couple of points or 3. When we graph them, Then we draw a line through them. And to find those points or pairs, you're going to need to complete some pairs or complete a table first. So here is a table. Make a small table here. Complete the table or the pairs. So X is always on this side, the Y is on this side. And again, if you have a table completed, or you can make up your own table. You can make up your own tables, choose small numbers. So math is easy. Small numbers, avoid decimals, avoid fractions, and so on. Easiest numbers to use are zeros. Easiest numbers to use are usually zeros. For example, 0 here, and maybe 0 here also. So these are the easiest one to use in addition to 1, -1, -2. So always use these two. These are special points. They have special names. We're going to talk about them in a minute. And then you may add a third one. 2 are enough to draw a line, but we add another one just as a check. We call it a checkpoint. Okay, another one just as a checkpoint to make sure if the third one ends up aligned, that means we're correct. But if the third one ends up off the line, here or here, that means something is wrong because they shouldn't end up like this. It could be this one that's wrong or the other one or all of them at the same time. So the third one is just a checkpoint. So just always use zeros, 0 on the Y, 0 on the X, so we can find these. And add another point. Basically any point, any points do you want to choose? For example, let's see if 4 works. Or maybe, let's see. Let's see another one, maybe 2 here, for example. Let's see if 2 works. If it's not one of these, then we'll change it. And we can actually, use maybe here, change this one, use this another number here, maybe 6, just a random number. You can choose any number, just make sure it's something that's easy, not complex. So we have the equation, we have an incomplete table. So before we turn this table into a graph, we need to complete the pairs. How do we complete these pairs again? We're missing X here, so how do we find X? In the first one.
Look for Y.
Look for Y. Let's call this point A. So how do we
Creating the
complete?
other formula.
What do we plug in the formula?
All right, so you plug in the Y.
So again, so we have the pair, it's incomplete. We have X and Y. So how do we use this to plug or to find the other value? What exactly do we plug?
We would not plug that 3. That's in front of the X.
So we have the pair here is incomplete. We have X, which we don't know, and the Y is 0. How do we find
You have
this
to
value?
plug the 0 in the equation where Y is.
That's right. So we plug the value that we have. In this case, we have Y 0. We plug it here. We plug it into the Y and then solve for the other one. So plug.
Okay.
It'll be
Plug
3x
Y.
minus 6.
That's right. So plug Y in the equation and solve for X. So you will have one, the other one is missing. Plug what you have, either the X or the Y, and you will be left with the other one which you need to find. And find X. So again, just like evaluating expressions, is 3 times X minus 6 times Y equals 12. Do we know the X?
No,
We don't know the X actually.
but we
It should
leave it
stay
like
there.
that.
Right.
Minus
And
6
then this-
times Y,
0.
which is 0. This Y goes here.
Mm-hmm.
And now it's a very simple equation to solve. The reason why we told you to use the zeros, they're convenient. That's gone. Okay, that's
Okay.
gone. End up with 3x.
3x equals
But it's
12.
2,
And
so
then
now you're gonna
x
carry over
equals 4.
the 3x to the 12,
We divide it. That's right. We divide it by 3. X
which is
is
4.
So
4.
0.
So the first,
So when y is 0, x is 4.
exactly. So the first pair
Right.
is complete. For y is 0, x is 4. So now we have 1 point on the graph. We're going to need to find at least one more so we can draw the line. If you have 1 point only, you're not sure which way to draw the line. Could be anywhere, but we need 2 points so we could know the way to draw it. So the first one is complete. Let's do the same thing and try to find the other one. So this time we're looking for B. We're looking to complete B.
X is 0. And we don't
That's
know
right.
the other.
So this time we're missing the Y. So the X is 0. So we're going to plug it here. Back to the equation again. We used it here. Restart all over again with the equation. So we're going to plug
0 in the x.
Plug X 0. Find Y.
Find Y.
It's going to be 3
So
times.
that's 3 times 0 minus 6y equals 12.
Exactly. So the 0 goes here. So that's 0. And again, because it's times 0,
We
anything times 0
cancel.
cancels out. That's right. It cancels out. It's gone. You end up with negative 6y equals 12. What
That's
exactly
y
do we do now?
equals negative 2.
The y would be negative 2. That means what do we do on both sides?
Divide by minus 6.
That's right. So we're going to cancel the negative 6 by dividing by negative 6. Also here. Cancels. So y is negative 2. So that's the missing number here. The other missing
So
number.
when x is 0, y is negative 2.
Exactly. And this is now a complete pair. So now if you plug both of these here, as we did earlier, if you want to check this, you can plug it here. You'll see actually that it worked. If you plug 3 here, 3 times 4 would be 12. If you plug 0 here, this would cancel out. 12 equals 12. You can also check the other one. So it's a complete pair, order pair. So if we plug this pair here, it should work. And the last one, since it's different, it's a big number, so it's probably going to be off the line if we use 6. But let's see what we get if x is, or for y is 6. Sometimes the numbers are too big; they might be off the chart of the graph. So try to keep the numbers small. So let's see if we can find the x here. If it's a small number, so x or c. So we don't know the x. The y is 6. Same thing. So we're going to plug the 6 here and see what we get. So it's going to be 3 times. We don't know the x.
3 times x minus 6 times 6 equals 12.
That's right. So the 6 goes here now because the y, we chose y to be 6. You can choose any other numbers. If one number doesn't work or it's complex, it's a decimal or a fraction, choose another one. Okay, just you're free to use any numbers, but these are always convenient to use. The zeros are very easy to use.
Professor, you mean that you're not always going to give us a table? We have to make it up?
Sometimes we'll ask you to make your own table, or use these points. These have special names. I'll tell you their names in a moment. So most of the time we'll ask you to do these first with the zeros. Then you may add another one.
Okay.
Okay, so let's solve this one for x. So 3x.
3x minus 36 equals 12.
That's right.
And then that's, you move
You
the
minus your
36 to the other
36 over the
side.
12.
So that's
Cancel out your
3x.
36.
We added, right?
Or you
Add
add it to
36.
both sides.
Exactly. So we're going to add it to both sides.
So you have 3x
That's what, 40?
equals
48, right?
Right.
And
48.
finally, divided by 3, x is
8? Wait, no.
16.
16?
Okay, so
All right.
this was a bigger number, so you don't want to use big numbers like these. So try to keep the numbers small. So 6, 16, this might be off of the graph. So try to use smaller numbers. These are enough to use, but it's always good to add another one just to check. So if y is 6, x is 16. And again, avoid using large numbers. You can use 1 and 2. but it may end up in a fraction here. If it's a complex fraction, try another number. If it's a fraction, like for example, 1/2, it's not bad. This is 0.5. This we can graph on the graph. It's between 1 and 2. But 2 are enough. Let's just graph these two for now. And we'll have our solution set. So these are just 3 pairs, but we have too many. Now let me copy a graph. I think I have a graph somewhere here. You can use graphing paper. You can print it out from the internet, or you can make your own graph. But to be accurate, it's better to use a graphing paper like this. All right, so let's see. Let's put these points on this graph. So 0, 4. 0, 4, x, 0, y, 4. So how do you plot this point? Where do we start? Where do we go? I mean, not 0, 4, 4, 0, x, 4, y, 0. So we start from where again?
From 4 in the X line.
So we're going to find the x on the x line. Let's write the x line here, the y line. So 4 is here. Then the y is 0. So what do we do from here? The y is 0. We're not going up. We're not going down. So what do we do?
I just put there, right there, where you're holding it.
And go to the left. I don't know. To the middle.
Not left. So we stay right here.
Stay right there on the 4.
Oh, got it.
Exactly. Stay on the 4. So the y is either up or down. It's vertical. Up or down. Up, it's positive. Down is negative. If it's 0, that means you stay here. The y is 0 here. You don't go anywhere. That's the first point. That's basically point A. Then we do the same thing for the other ones. This time 0, -2. So where do we start? Where do we go?
-2 is in the part on the, I don't know how to, and the negative part of y.
We start from the x. Start from the x first. So,
But x is 0.
okay, so where is x 0? On the graph.
Down.
In the center.
The same line.
That's right.
In
So,
-2.
so 0 here, both x and y are 0 here. Both x and y. So it says here x is 0. That means it's in the center of the graph. And the y is -2. So what we do from here?
Go down until -2.
Down. That's right. Twice. Go down to -2. This graph actually is not accurate. I don't like this graph because the 1 actually -1 is here. 0, 0, -1. Okay. So this is -1, -2 is here. And that's it. So we have the 2 points. Yeah, so because the number is a little big, so 16 is off the graph, so we don't see 16. We need x16. We just have up to 11 or 12, 10 or 11. So that's why we should use smaller numbers. And that's it. That's all I wanted. Just
Oh, Professor, I have a question. In
Yeah.
regards to that, like when we have like a high number and it's not like noted on the chart, do we just indicate that with arrows?
no, choose another number. Choose something smaller. Okay, for example, try 2 here.
Okay,
We didn't,
gotcha.
we didn't
Thank
use,
you.
yeah. You can choose, for example, 1 here or here, -1, -2 before we get to the big numbers. I don't know why we put 6 here, but it's not a very convenient numbers. A, this is B. And that's it, that's our line. So any point now from this line will be a valid solution. What are, for example, what are the coordinates? What are the x and y of this point? Let's call it C. What's the x and y of this point? So drop it over the
6
x.
and 1.
That's right. X is 6. And then if you want the y, drop it over the y horizontally like this. You get 1. And if you plug it in, if you plug that here, it should work just fine. Let's try it. 6 and 1. X is 6, and 1 here. You can see 3 times 6, it would be 18, minus 6, it would be 12. So any number, any point from the graph will be a solution to the equation. But any number that's not on the line, if you take a number from here or here, it's not going to work because it's not a solution. So the solution set is a straight line, and that line we can easily graph by completing the pairs. So as I mentioned earlier, always try these two first. If you have a table or if you don't have a table, if the question doesn't give you a table, you can make your own table by using the zeros. These are special points. This point A and B are special points. We call the first one 4, 0. 4, 0 is here. That's A. We call this the X-intercept because this is the intersection of the X-axis and the line. That's why we call this the X-intercept. X-intercept. And this is the y-axis. This is the line. What would we call this point here where the line meets the y-axis?
Y intersection.
That's right. We call it the y-intercept. Y-intercept. Let me write it again. So the x-intercept is where the line meets the x line, and the y-intercept is, as you can see, and both these points are special because they have zeros in them. For the x-intercept, this one, the y is 0. For the y-intercept, the x is 0. So this is the first point for is A. Okay, A for 0. This is it for 0. So this point is the x-intercept. So that's the x-intercept. And the other point B, this is B, because it has 0 here. That's why it's on this line. That's why it's on the y-axis. So B is the y-intercept. So these points are special. So remember, so when the y is 0, the point is called x-intercept. When the y is 0, not the other one, when the y is 0. And also, if the x is 0, we call the number the y-intercept. So if you have these numbers that are easy to complete, and they're easy to graph, you are on the lines on the x and the y-axis. So a lot of times the question would say, find the intercepts and graph the line. This is what we mean by intercepts. So there's two of them, xy and yy. The xy, the x-intercept is where the line meets the x-axis, and the y-intercept is when the line meets the y-axis. So these are special, or they are convenient because they have zeros in them. They're quick to do. They cancel something, as we saw here. So always use these. Unless the question gives you a specific table, then you fill out that table. But other than that, feel free to use these. They're very convenient and easy. And two of them are enough. And the third point is just, I would say it's optional. It's a checkpoint. You can add it. But at least need 2 points to graph a line. So these are the special points. So remember them, they have zeros in them. Put 0 on the y, put 0 on the x, and complete the pairs. Whenever you graph a linear equation like this. Okay, everybody, does that make sense about the intercepts?
Yes,
Everybody?
as much as possible.
Yes.
Okay. Everybody else, please let me know if you have any questions about this. We may do another one. So remember the intercepts, they're special, they have zeros in them. So we completed the pair here. So the x was 16 The pair here, we completed it. Missing number was -2. Also here, 4. So that's basically how you graph any equation. Any equation you can graph it this way, and you can check any pair. You can have any equation, have any pairs. All you have to do is plug them in and check, see if they're solutions or not. And yeah, that's basically it. It's how you solve equations in 2 variables. And remember these. Remember, these are very useful. We're going to get back to them in the future. Let's do one more. I'll give you one more example. And let's say 4x plus maybe 8y, and maybe here, say -2. So a typical question would say, find first of all, if it says just graph, you'll know what to do to graph. It may give you a table, or you can make your own table, preferably with the zeros. Fill out the table and graph. Or a lot of times it would say, find the intercepts. Find the x and y intercept, or it would say just the intercepts. So when you say the intercepts, we mean the x. Find the intercepts and graph the line. All right, so the keyword here is find the intercepts. What does that mean again? What do we mean by the intercepts? So we're going to need a table. The table of x and y. What are the intercepts, the special intercepts? There's some zeros, right? Where do we have the zeros?
You can put a 0 on the first chart on the X and then on the second one on the Y.
That's right. So whenever you hear intercepts, you do a table like this, make a 0 here and a 0. That's what we mean by the intercepts. That's what it means. It could be written like this. It may also be written as incomplete pairs like these. It might be like this. So the first one, this is A and B, or it could also be like this, A and B. So we have Y here, we're missing this. For the second one, we have B, and we have B, which has X, we don't have the Y. So it could be as a table or as a couple of pairs. Okay, so let's complete the first one. Same way we did before, we have Y, we don't know X. What do we do again to find it? What do we do here to find the
You
X?
plug the 0 in the corresponding letter. In this
That's right, you
case,
can
in Y.
actually, that's right, you can actually look at it. If we plug 0 here, this will cancel out. We would have 4x equals -2. Should have used, let me actually change it a little bit so we don't have fractions. We don't want to deal with fractions yet. Let's see, maybe this. So as you can see, these are very easy to use. So if you have, for the y is 0, if you plug 0 here, this would cancel out. So 2x would be equal to -4. And what would the x be if you divide by 2? Well, let's write it down. So 2x plus 8 times y. Again, the y is 0, so we're going to put 0 here, equals -4. So this is a point A. So point A, we have 0, but we don't know that. We don't know this one. We don't know the x. Okay, as you can see now, because it has a 0 in it, anything times 0 cancels out. End up with 2x equals -4. That means x is, everybody, what is the x here? I think I may have lost.
-2.
That's right. X will be negative 2. So if we divide by 2, divide by 2, X will be. So the number that's missing here is the negative 2. Now let's do the same thing and complete the other one. B, this time we have 0 in the X. We don't know the Y. So again, we're going to plug 0 here and find the Y. So it's going to be 2 times 0. This 0 actually goes here. This one here, this 0 is what goes here. Plus 8y. This time we don't know the y, so we're looking for it. It stays here, equals negative 4. So again, cancel the term with 0. So if you use some other number other than 0, it'll be for example, you use 3, it will be 2 times 3. You will still have a 6 here, but the zeros are gone right away. So that cancels that immediately. So we can have 8y equals negative 4. And what is the y equal to? What is the y equal to here, everybody?
4.
By 4.
Not 4. If you divide by
It's gonna be
8,
negative 4.
48. 8.
it's not negative.
No, it's not. It's
Reduce it. It's a fraction. Reduce it. It will be 1/2,
yeah.
right? Or 0, negative 0.5. So to graph, to locate a coordinate that has a fraction, just make it a decimal, just like we did with the number line before. So we know exactly what to find this number. So again, we're going to need a graph. Just have to put these 2 points somewhere. So the first point, again, we have negative 2 here, and this is negative 1/2. Negative 1/2, which is negative 0.5. So let's graph these now. So negative 1/2 or negative 0.5. How do we graph this one again? What do we do to plot this point?
On the line.
On the X line, the negative 2.
So X is negative 2 on the X-axis. So it's going to be here. So
And
it's on the
the
left
same
side
line.
this time. And where do you go from here? The Y is 0. So what do you do?
That's it. There.
You stay there.
That's right. Stay right here because the Y is 0. We either go up or down, or we stay here, not left or right. So we start from here first. It's negative 2. And that's the first point. This is A. And what is well, how do we find this other point? Where do you start? Where do we go to find the other point?
Just below 1 and in the same Y line.
So we start from X0, which is in the middle. Then we go down right in the middle.
In the middle. In the
Okay.
middle.
So this is negative 1. Negative 1 is here, so just one negative 0.5. It's in the middle between 0 and negative 1. So that's our second point. So that's B. You did at least 2 points. This is A and this is B. And again, we need to insert the line. As to go through both of them, again, make sure you use a ruler and graphing paper when you do this. The homework, I believe, it will give you a graph. It will give you a graph, and you can adjust the lines like this. You can insert lines and you can insert points as you wish with when you do the homework. Something like this. So that's our line. Okay, so again, to graph a line, use the 2 points, the intercepts, the special one with the zeros, plug them into the equations to complete them, then plot the points into the graph and draw a line through the points. That's how easy it is to graph points using the y-intercepts. We have another method. We're going to learn that in the future. Another method, easier than this actually. It takes seconds to do without this solving, but we're probably going to see that next class. So This is again the x-intercept. And the other point is the y-intercept. So these are special again because the x-intercept is this one. As you can see, the x-axis meets with the line, and the y-intercept is when the y line meets our blue line here. So this is again x-intercept, and this is the y-intercept. And that's pretty much it. That's how you graph or solve linear equations. It is pretty simple. We do the same thing every time again, plug, find the missing values, and then put the points on a graph. Or you may check a pair. It may give you an equation, give you some pair, and I'll ask you to check if it's a solution, which you do simply by plugging the points into it. Okay, that's pretty much it for tonight's lecture. Any questions, everybody, about any of this, especially the last part, or any other problem we've done today? Everyone, all of the people in the room, 20, 21 of you or so. Any questions, please let me know.
I sure will. I always get problems with this, but I'm glad that it's recorded. So if anything, I could just always follow up.
Yeah, definitely. You'll find the recording. Okay, so this summarizes everything we've done. We've done pretty much the same thing over and over again. We have an equation. You can complete a table. Might be given to you, or he may ask you to use intercept, which is this, the zeros. So the intercepts mean the zeros. Or if he doesn't tell you what to do, be free to use whatever you want to use, whatever numbers, but I recommend using the zeros. Once you complete your tables, you put them on a graph, and that's pretty much it. Okay, let me know if you have any questions, or actually let me give you one example. Give you one to do by yourself. Again, it's not easy until you can do it by yourself. Do on your own. It is easy, but practice makes perfect. So let me give you one here to do by yourself. So complete the table. And graph the equation of the line. Let's see, so maybe 3, 2, maybe 4. So for x, for example, minus 8x, and let's see, maybe 16 here. So again, complete the table. The table will be made of 0 here, 0 here, maybe another number, another points. So this is again what we call the x-intercept, the y-intercept. So complete this and graph it. And check if you have a pair, check if it's a solution. 2, 1 is a solution. To the same equation. That's the first one.
You put 4x and 4x minus 8x.
Right, should be.
Y.
Should be our y. That's right. That's right. Has to have x and y. Okay, so that's pretty much sums up everything we've done today. Checking an equation and graphing an equation. Very simple stuff. I'll give you a lot of time to do this. Okay, I'll give you about 8-10 minutes or so. So again, try it yourself. It is easy, but don't assume it's easy until you try it yourself. It's the beginning of few classes. The next maybe 2 or 3 classes, we're going to be talking about equations a lot. Equations with 2 variables, a lot. So make sure you understand this to make it easy for the next few topics based on this. All right, work on this and I'll see you in a few minutes. You may take a short break if you would like to before you do the practice. And I'll see you in a few minutes. Everybody, let's go over this problem. What is the missing number here?
4.
That's right, 4 here. And for this one,
-2. No,
-2, okay. And
Wow.
the other one is probably a fraction. If x is
Yeah.
1,
3
What is it?
over 3 over 2 equal to 1.5.
okay, 3 over 2 is 1.5. Everybody else, you got the same value for this one? Everybody, did anybody else get
Yeah.
3 over 2? Okay, so that's good. So now we have these points. What do we do with them?
Graphic them.
That's right, I'm gonna put them in a graph. And the graph will be something like this. All right, the first point. How do you graph the first point? 4, 0. We're going to start from 4 and
And leave it there. The
stay
point.
there.
right,
Stay
you
there.
stay on this line because the y is 0. The other one, 0 minus 2. So what do you do?
Go below -2 and stay there.
Start from 0
And
on the x
the y
and go
line.
down. This is -2. The other one, 1 and 1.5. So we're going to start from 1 and go. So this is not correct here. This is wrong. It could be, it's probably a negative. Start from 1 and go down to 1.5. Okay, so we start from 1. Should be a negative because of this negative here. So -3 over 2. Start from 1 and go down to 1, -1.5. -1.5 is about here.
Yeah, I
So
forgot
all
to
the
say
points,
negative.
that's right. All the points are aligned, A, B, C. So again, this is A and B and C. So now we just need to draw a line through those numbers. And the graph would be complete. That's it. And what about this pair? Is there a solution?
No.
Everybody? If you plug this, right? If you plug 2 here, it would be 4 times 2 minus 8 times, this is x and y, times 1. We say that equals to 16. That's 8. 8 minus 8. And is it equal to 16? No, it's not equal to 16. So this is not a solution. This pair is not a solution. But any pair from the line, if you plug it, it will be a solution. Okay, so again, that's how simple it is to graph linear equations with 2 variables, and also easy to check the solutions. And we're going to see this over and over again in the upcoming classes. Any questions, everybody? Any questions about this problem or any other problem we saw earlier?
Good.
No question.
Mm-hmm. So please let me
No
know if you have any
questions.
questions. All right. And that concludes today's lecture. So I sent you an email and I posted an announcement about the midterm on Blackboard. So the midterm is in week 10. This is week 8.